Okay, this is a quick tutorial on how to create Newtonian gravity inside Unity. And by that I mean bodies that attract each other. So they've got mass, and they have gravity, and the bodies attract each other. I've never done this before, so I don't know if it's going to work. I hope it will. Let's get started. So open Unity up, and I'm going to create just two new spheres on here. Here we go. So they've got sphere, and then to each sphere I'm going to give it some physics. So I'm going to give it a rigid body, and I'm going to give it a mass. This one here I'm going to give it a mass of 1. I'm going to copy this. In fact, I think I can just do duplicate. There we go, lovely. And this one I'm going to move a little bit to the side. We'll change the camera angle in a second. So if we come around here, let's go to the main camera, so they're kind of facing each other. Let's just, in fact, I'll tell you what, why don't I just move this around that way? Okay, cool. So we've got two spheres, and one of these spheres has got a mass of 1, and the other one has a mass of, we're going to create 5 for now. Cool. Okay, I'm not going to use gravity. It's weird. Why wouldn't I use gravity? Because the gravity in Unity is a physical gravity, presuming we're on the Earth. This model I'm doing is no gravity, i.e. it's like in space, if you want to call it that. So there, and now what I need to do is I need to create some lighting. So I'm going to give it a light, if I can remember where it is. So we'll create a directional light, I think. Perfect. Now what I'm going to do is create a couple of materials. So create a material. Here I'm going to call this red, and guess what color that's going to be? Yep, lovely. And I'll create another material, and I'll call that one blue. Fabulous. Okay, so, and that's my blue color. Lovely. Now what I'm going to do is this sphere, I'm going to call it Planet X, and this one I'm going to call it Planet Y. That doesn't really matter, that's just for lols. If we go to the planet itself, I'm now going to go into the actual renderer, the material section, and this material is going to be red, and this material is going to be blue. Thank you for that text, whoever that was. Lovely. The other thing I'm going to do with this is, this has got a mass of 5. I'm actually going to make it like a bit of a smaller planet, so I'm going to mess with the scale of this one. I'm going to say it's got a 0.5 scale, 0.5 scale, 0.5 scale. So even though it's a smaller planet, it's heavier. Okay, so if I just run that, we shouldn't see anything. Yeah, we've got 2 static spheres. Not doing a lot. Great. Okay, cool. So now what I'm going to do is I'm going to create a new empty object. I'm going to call this I'm going to call this Game Manager, and the Game Manager I'm actually going to add a new script, and this is going to be a C# script, and I'm going to call this script Game Manager. Okay, it's not really a game, but let's create and add it anyway. Awesome. Okay, let's go to Game Manager. There she is. Lovely. Sorry. That's going to pull up MonoDevelop. Now fortunately on Stack Overflow, which is here, not on Safari, someone else has already got the routine for me on how to calculate and apply gravity to fixed body objects, basically. Now, this is based off Newtonian gravitational physics. So if you go into Newton's law of gravity, gravitation here, and you go to like Wikipedia, you'll see here there's a really great diagram that explains the mathematics between it, and it's pretty actually simple. There's a constant force here called gravity. The 2 bodies have a mass, and they have an attraction to each other, force 1 and force 2, and they sum it up by saying it's something about every point mass attracts a single other point by force. The force is proportional to the product of the 2 masses and inversely proportional to the square of the distance between them, which sounds very complicated, but all it means is that squared divided by the mass multiplied to each other times by gravity is the amount of Newtonian force. And this guy on Stack Overflow has already done the method for us. So I'm going to grab this method and I'm going to stick it in my new class, which has been created here. Here it is. So that's being applied to two rigid bodies, right? Which is cool, and it's a fairly straightforward calculation. Then what we're going to do is we're going to go into his other bit of code, which is a fixed update. Now, if you're new to Unity, a fixed update, all it is it's an update here can be executed at any time inside the application lifecycle. You don't know when it's going to happen. It might happen within a millionth of a second, or it might happen within 25 milliseconds. Okay, it depends on the processor speed. Fixed update means it gets fired on a regular interval. I think this is kind of like a bad way to do it, because you should really be using the update command and then altering the time constant that gets fired in Unity. I think that's the proper way to do it. However, okay, so that doesn't matter. So what this is going to do here is it's going to apply gravity to the rigid body of the objects. This presumes every object in my scene is going to have a rigid body associated with it, which it does, because I added them at the start of this whatever it is, this tutorial, this video. Okay, so I don't know if this works, by the way. I've just literally pulled it out of Stack Overflow, which is possibly the best invention ever by mankind. Right, let's go back to Unity, which is cool, which is here. And what we're going to do here, so we've got our script running. Something it's looking for is tags. So, yeah, so it's looking for tags. When we looked in the script itself, we could see find game objects with tag object. I'm going to change that to say planet, because I don't like looking for. I don't like this anyway, but sure, it's fine. It's going to work, I think. Let's go into here, and we need to change the tag. So we're going to add a tag here, and we're going to call this one. What would I call it? Planet. Okay, cool. So now if I go into, oh, that's spelled incorrectly. Spelled that correctly. It's difficult because I think there's a glitch in mine. This one here can be planet, and this one here can also be planet. And at this point now, I think it should all work, or something should fire. Right, it's moaning about an aspect of G here, so there's no G. He's remmed that out. That worries me a little bit. G isn't right there anyway. So let's go back to his example of code. So G is a constant. Right, I'm going to pause this a second while I find out what the actual value of G is. The value of G is 6.67 times 10 to the power of minus 11 newtons per meter over kilograms per squared or something. But I'll find out what the actual number is and we'll continue. So just bear with me a sec. Okay, so yeah, welcome back. Sorry about that. Had a few glitches with the script that was supplied on Stack Overflow, which I'll post a reply to let other people know what the problems were. If we go to MonoDevelop, I'll show you what I did. Basically, first of all, in fact, I added this. I didn't need to add this because I changed the way it was going to work. First of all, this objects variable wasn't defined. He might have been defined in his code somewhere else. But here, obviously, I need to create this as an array because it's finding back multiple objects, right? So that's an array. Second of all, yeah, it was a bit stupid this really, but all I had to do was just create the double gravity here. So I grabbed this off Wikipedia, the math for the gravity from here. So here it is, 6.67 times 10 to the power minus 11. I've done it to 10 to the power of 11 because I want to track basically the force is attractive, right? So if I now run that in Unity, so again I will post this up as a response to the Stack Overflow question so you can see it. Let's go back to Unity. So now if I run that, you'll see that we get our items colliding. Okay, cool. So let's zoom in a little bit. So in the camera setting, let's go in a little while. So here we go. and this time let's take the distance of, I think it's this planet here. Yeah, not this planet. Let's try this one. Let's try the distance of this planet here and put it like right at the back. See what we get. So we've got a slow attraction of gravity there. In fact, to tell you what we could do is, what's useful is if I take off the maximize on play, then what I can do is I can look at the I can see in the top window here, because you can easily manipulate your way around this window. So let's take that off and let's run it from here. So there we go, we can see the two bodies, boom, collide, great. Okay, so that's great, but we kind of want them maybe to have a bit of velocity. So I said I wasn't going to use gravity before. I think I probably am going to use gravity. Okay, so I'm going to use gravity, but I'm actually going to turn gravity. In fact, do I need this or not? I'm not sure. I'm not sure whether I need to turn gravity on to add force. I don't think I do. So you see, I'm adding force here. So maybe what I'll do on the start is I'll do the same thing. I'll go through each object, but I'm gonna instead of applying some gravity to this, I'm gonna add some force to them. Yeah. So here I'm not actually gonna go. I just want to go through each one. I don't want to go through testing each one. I'm gonna say object A dot. I think it's the rigid body that's on this dot add force. And then I can add a new vector. So let's just add a new vector. I'm going to add, just to experiment to start off with, which plane are they on? So I kind of want them to go, if I look at planet Y, excuse me about this, I'm just kind of doing this one. So I kind of want it to add on the x-axis, don't I? Because I want it to have that type of orbit. We could add all sorts of orbits, but let's add on this axis a new vector 3, and it's going to be on the x-axis, so I'm going to add 10, and then I'm going to add nothing on the y-axis. In fact, I wonder if I can get, yeah, okay, and I'm going to add nothing on the z-axis. That will give them both the same amount of force. But because one's got more mass, it should be different, the way that it works. Let's have a look. So probably, oh, there we got a little bit of kind of like an orbit, although I think they're kind of stuck on each other. Probably didn't give enough force. Adding force to the one with less mass is going to move it more, obviously. Let's try adding, in this case, let's try adding 100. I'm playing here, by the way. I don't know what the correct values are. So what happens now? There we go. So we got some very interesting kind of stuff going on there, right? So you can see as it comes in, it swings around. That's beautiful. That's exactly what I was looking for. So we got kind of like Newtonian force in play here as it comes in. The distance speeds up the attraction. It's really beautiful. And this is all courtesy of somebody who was born in 1600 and something. If only he was alive today and he could see an idiot like me, you know, kind of making use of his knowledge in a little computer demo. Absolutely fabulous, though. I hope you guys enjoyed this as much as me. That's it for this little quick tutorial. I can post the code somewhere if anybody wants to see it. I hope you enjoyed it. Good luck, and I hope you can write your next version of Elite or whatever with it. Thanks so much for listening, everybody, and bye-bye now. Take care. Bye.